In this third lecture video on momentum and collisions, we will go through an example related to impulse and momentum, which we discussed in the previous video. A 15.5 gram bullet is fired at a muzzle velocity of 644 meters per second from a gun with a mass of 6 kilograms and a barrel length of 65 centimeters. There are several questions we want to answer about this problem. First, how long is the bullet in the barrel? Next, what is the force on the bullet while it is in the barrel? Next, find the impulse exerted on the bullet while it is in the barrel. And finally, find the bullet's momentum as it leaves the barrel. The first thing we want to find is how long the bullet is in the barrel. We will first write down all of the data we are given. The distance the bullet travels will be the barrel length of the gun, which is 65 centimeters. Since we have units of meters per second and momentum should be in kilogram meters per second, we will convert our distance in centimeters to meters by dividing by 100. This gives us a distance of 0.650 meters. The final velocity is going to be the velocity the bullet exits the gun, which is 644 meters per second. The initial velocity of the bullet is 0 because before it is fired, it isn't moving. Since we know initial and final velocity, we also know the average velocity, which is the final velocity minus the initial velocity divided by 2. Therefore, the average velocity of the bullet is 644 meters per second divided by 2, which is 322 meters per second. Next, we will need a basic equation to solve for time. We know that S equals the average velocity times time. This is the length of time the force is applied to the bullet. We will divide both sides by average velocity to solve for time, which equals the distance S divided by the average velocity. Next, we can substitute the data we were given, so time is equal to 0.65 meters divided by 322 meters per second. This means the bullet was in the gun 0.00202 seconds. Now we want to find the force on the bullet while it is still in the barrel. Even though this is one large problem, I would recommend rewriting your data down at each step. The initial velocity is still 0 meters per second. The final velocity is still 644 meters per second. The mass that we need this time is the mass of the bullet because we are trying to find the force acting on the bullet. The mass of the bullet is 15.5 grams. Ordinarily, we want mass in kilograms, so 15.5 grams is equal to 0.0155 kilograms. The time from the last step is 0.00202 seconds. This time we are trying to find the force F. We will look at the impulse momentum equations to find our basic equation. Since we are trying to find force, but we have time, mass, and final and initial velocities, we will use the equation force times time equals mass times final velocity minus mass times initial velocity. We want to solve for force, so we will divide both sides by t to get a working equation of force equals mass times final velocity minus mass times initial velocity, all divided by time. Next, we can substitute in all of our data. So force is equal to 0.0155 kilograms times 644 meters per second minus 0.0155 kilograms times 0 meters per second, all divided by 0.00202 seconds. The second term in our equation is equal to 0 since the initial velocity is 0. Calculating, we see that force is equal to 4,940 kilogram meters per second squared, which is the same thing as 4,940 newtons. Next, find the impulse exerted on the bullet while it is in the barrel. For this part, we only need some of our original data. We know that the time is 0.00202 seconds, and the force from the previous part is 4,940 newtons. We need to find the impulse. The basic equation for that is impulse is equal to the force multiplied by the time. This will also be our working equation since it is already written in terms of impulse. Next, we will substitute in our data. So impulse is equal to 4,940 newtons times 0.00202 seconds. This gives us an impulse of 9.98 newton seconds. However, we can reduce the units and see that it should be 9.98 kilogram meters per second, which is what the unit for impulse and momentum should be. In part D, we need to find the bullet's momentum as it leaves the barrel. Since we are calculating momentum, the only pieces of data that we need are the mass of the bullet, which is 15.5 grams, or 0.0155 kilograms, and the velocity of the bullet as it leaves the barrel, which is 644 meters per second. We are trying to solve for momentum P. The basic equation to solve for momentum is P equals m times v. Since it is already written in terms of P, we can substitute right away to see that P equals 0.0155 kilograms times 644 meters per second. This gives us momentum of 9.98 kilogram meters per second. The impulse from part C equals the change in momentum in part D. This concludes our discussion on impulse and momentum.